All right, let's talk about one of the biggest, most nerve-wracking challenges in software today. How do you roll out brand new, potentially game-changing features without, well, blowing everything up? We're going to get into how you can architect for safe experimentation right where it counts the most, in production.
You know the feeling. We've all been there, right? You're just about to hit that deploy button on a huge release. Your heart's pounding. Is this going to be the moment you're a hero? Or is this the moment the whole system just catches fire and every pager in the company starts screaming? That blend of pure excitement and absolute terror is exactly what we're here to solve.
For way too long, we've been told we have to pick one. You can either move fast and break things, or you can move slow and be safe. But what if that's a false choice? What if you could actually build a system that lets you innovate at lightning speed while keeping everything rock solid and stable? That's exactly what we're going to break down today. Okay, let's just dive right into the core conflict that sits at the heart of all of our work. I call it the production dilemma. It's this constant tug of war between the business wanting to innovate and ship features and the engineering team's absolute duty to just keep the lights on. And the stakes here could not be higher. On one side, you've got all this pressure for innovation, you got to get to market fast, you need that competitive edge. But on the other side, the risks are just huge. Bugs that your customers see, direct hits to your revenue, and that kind of damage to your reputation that is so hard to fix. This is the tightrope that every single architect is walking every single day. So, how do we actually solve this dilemma? Well, it's not by being afraid of production, it's by embracing it, but intelligently. And we do that with a really powerful set of tools and techniques that are designed specifically for testing safely in a live environment. So let's open up the toolbox. First up, we've got the canary release. Now, the name comes from that old practice of miners using canaries to detect toxic gas. In our world, a tiny percentage of users, like maybe 1%, there are canaries. They get the new code first. If anything starts to look weird, if they start having problems, our smoke detector goes off and we roll it back before anybody else is affected. It's our ultimate early warning system. Next up is the A/B test. Now, this is less about stability and way more about effectiveness. Is the thing we're building actually making the product better? With an A/B test, we might show half our users the old blue button and the other half a new green button, just to see which one gets more clicks. It's not really about finding bugs. It's all about using real data to find the best possible user experience. And then there's the dark launch. This one might be my favorite just because it's so clever. You deploy your new code to production, it's running, it's handling real traffic, but no user ever sees it. It's like a full dress rehearsal for your backend. You can just hammer your new microservices with real-world load, check for performance issues, all with literally zero risk to the user. So looking at these all side by side, it really clarifies when you'd use each one, right? A canary release, super low user visibility, is perfect for those really risky infrastructure changes. An A/B test, that's high visibility, and it's all about optimizing how users behave. And a dark launch, zero visibility, which makes it the absolute go-to for backend and performance testing. It really is about picking the right tool for the right job. Okay, so theory is great and all, but let's see how this whole thing comes together in the real world. I want you to imagine you're the lead architect, and you're in charge of a massive feature rollout across a global multi-cloud platform. So here's your mission. The feature is absolutely critical. Your infrastructure is spread across multiple clouds, multiple continents. Your main goal is to get this thing launched everywhere, but you cannot have a global outage. You have to prove it's stable, region by region. So, how do you do it? You do it by layering your tools in a really smart sequence. Step 1, you start with a global dark launch to make 100% sure the backend can handle the load. Step 2, you move to a tiny canary release in just one region, maybe the EU. You pick it because it's a smaller user base or it's off-peak hours. You send it just 1% of traffic and you watch your dashboards like a hawk. If the canary survives, then you move to step 3. You expand to a 50-50 A/B test in that same region to prove the feature actually makes things better for users. And only then, once it's totally validated, do you move to the final step, a careful, sequential, full rollout to the rest of the world. Now, you might be sitting there thinking, wow, this sounds amazing, but it also sounds like a ton of manual work and monitoring. And you'd be totally right if it wasn't for the most important piece of this whole puzzle, the automated safety net that we call guardrails. I just love this quote because it nails the relationship perfectly. All these experimentation techniques, they're the engine that gives you speed. But the guardrails, they're the advanced braking system, the traction control that lets you actually use that speed safely. They are what lets you sleep at night during a major rollout.
So what makes these guardrails so powerful? They're automated systems, and they are always watching. They're monitoring performance for any weird latency spikes, they're tracking error rates, and this part is crucial, they're even watching your core business metrics. Is the new feature tanking your signups? If any of these metrics cross a danger threshold, the ultimate guardrail kicks in, an automated rollback. The system just reverts the change instantly, no human intervention needed.
You know, when you start to put all these pieces together, the experimentation tools and the automated guardrails, you end up with something that's much bigger than just a set of practices. You arrive at a whole new philosophy for building software. And honestly, it often requires a big cultural shift across the entire engineering org. And this right here, this is the main takeaway. The old way of thinking was trying to prevent every single possible failure, which, let's be honest, is impossible, and it just leads to slow, brittle systems. The modern way is to accept that failures are going to happen. So instead, you architect systems that can handle those failures, that can contain the blast radius, and that can recover automatically. You build for resilience, not for some imaginary world where nothing ever breaks.
By embracing this whole philosophy, you literally transform launch day from something terrifying into something empowering. You finally get to have both speed and stability. So that really just leaves one question for you to think about. Now that your infrastructure is ready for it, what's the first bold experiment you're going to run?